Yeah, hello everybody. I guess we've gone live, and welcome to the second 5G Impact in Maritime Connectivity hosted by the BG Group. Today's sponsors for the event is ST Engineering and iDirect. Myself, I'm Stig Petersen from SINTEF. I'm the moderator and also a presenter today due to some unfortunate COVID on the moderator. I've stepped in on the last minute here. So with us today, it's myself, Stig Petersen, and we also have Kris Vedat, Head of Technology and Logistics at P&O Maritime Logistics. And another Kris Insall, Head of Mobility and Business Development in ST Engineering, iDirect. So we have 3 presentations for you. The format is we will talk for 15 minutes each, starting with me and then Kris, and then followed by Kris. After each presentation, we will have 5 minutes for Q&A, and you can put Q&A into the chat under the Q&A tablet, and then we'll deal with the questions after each presentation. So after 1 hour, we still have 30 minutes left where we will do a, let's say, plenary Q&A session, the 3 of us all together, and maybe discuss some topics of interest, or if you have any further questions, and we can discuss between the 3 of us. So unless Kris and Kris have any questions or anything, I guess we can start with my presentation, which will delve a bit into the 5G technology. That's why we're gathered here today. I'm a researcher at SINTEF working with industrial communication, and the topic of my presentation is basically just an introduction to maritime 5G with a technology focus. So I think I'll just dive right into it and start with some of the fundamentals we need when we talk about 5G technology. And that's the components that make up a mobile network. So you have 3 main parts, should be known to most of you. The most basic one is the user equipment, which is traditionally a cell phone, a mobile phone. With the introduction of 5G and IoT and usage for other things, the user equipment may be sensors or devices or robots or drones or even a ship could be classified under user equipment using this network. User equipment connects to a radio access network. Traditionally, this is a national network in each country consisting of thousands of base stations interconnected to form a network that provides coverage basically to all areas of interest where there are people or activity. This network is handled by a centralized core network doing authentication and identification of users and billing and handling of data and traffic management, etc., network management. So these are the 3 components that we'll come back to. The combination of a core network, typically centralized in some location relevant to each network operator. That's part of a national infrastructure. And each country typically has 2 or more providers of wireless or of mobile networks. In Norway, we have 3, for example, and they all have redundant infrastructure. So we actually have 3 sets of radio access networks and core networks from 3 different mobile network providers in Norway. And in other countries, it's probably similar. So 5G is basically just the 5th generation of mobile networks, but it's the first one to try to address other things than just consumers and cell phone market. So what's new in 5G that makes it relevant for industry and across several verticals, such as maritime? The most important thing is the radio technology, which is called 5G New Radio. So the wireless interface or the communication interface, radio interface between the user equipment and the radio access network is new and improved compared to earlier generations. So this wireless link is now different. And what we see in the rollout of 5G that's being done by the mobile operators in the initial stages in the last years, that's to upgrade the radio access network, to put new access points with the new 5G wireless radio technology. And that's also what's being implemented in new smartphones from the different manufacturers. Other parts of the network, the core network, will also be upgraded with new features in 5G, but that's taking some more time. So at current stage, most of the public networks are basically a 5G wireless infrastructure using the 4G backbone system. In 5G, in order to, let's say, cater to the demands of industry and verticals, they have made improvements to quality of service related to the communication to be able to serve applications with stricter demands and higher reliability and lower latency that you typically find in the consumer use of a cell phone, where most people just download data, either video or pictures, etc., and do surfing online. So in this case, if you want to use a mobile robot, for example, in a factory using the public network, you just connect to your local base station with this new quality of service features in the RAN and the core network. You can get a dedicated slice called network slicing. So regardless of other users or the amount of cell phones or the amount of traffic in your local area of the network, you will have dedicated resources. So you can actually pay for and get an agreement with such and such latency or performance. Maybe you want 20 megabits per second data or 50 or 100. Then you can actually reserve that capacity in the public network through agreements with your mobile network operator and make sure that your system will work regardless of other use. Because traditionally in 4G and earlier systems, it's everybody fights for the same resources. There has not been any prioritizations of different usage, etc. So if you want to, you can get a dedicated resource or a part of the network called a network slice. For most of you familiar with 5G, there has been some talk about the 5G pyramid to try to distinguish the different use cases or usage scenarios you envision that 5G will address. And at the top of the pyramid is the traditional broadband use, which is basically just a faster version of 4G with capable of serving more users with higher data rates than 4G. So it's for broadband applications, surfing, video, HD video, etc. And what's new is down to the right here. You have a reliable and low latency communication used for example, motion controls for robots and drones and AGVs, etc., which is more industrial communication, which is different. And this is new in 5G and not supported in 4G. And in the third corner, you have your more traditional IoT applications with low power sensors sending data from time to time, which they call massive machine type communication. Now the status now is that the 5G new radio, the new radio interface and wireless interface for 5G is capable of serving both the eMBB and URLLC applications. So you have high data capacity, or you can tweak and tune the radio differently to have higher reliability and lower latency, of course at the cost of capacity and data rates. You can't get it all at once. Unfortunately, 5G has not been able to address the specific requirements for IoT. So when it comes to low power operations, lots of devices at the same time, etc., they have just, let's say, moved forward with the 4G technologies that you may know of with NB-IoT and LTE-M. So these are all the radio interfaces from the 4G specification that has just been updated and integrated into the 5G standardization. So from an IoT perspective, there's nothing new in 5G. Another usage area that's not covered in the pyramid, so to speak, but is very relevant for maritime communication, is that 5G will include support for satellite communication through what they call non-terrestrial networks. So that you can have a, let's call it a user equipment that communicates through satellite as usual to a ground station, and then you can incorporate this communication into the framework of 5G from a core network perspective and use the same authentication and data networks, etc. We will have a separate presentation on satellite communication with 5G from Kris later today. When it comes to frequencies and also the capacity and expected data rates and throughput of this system, initially there are two pioneer bands for 5G new radio that's been developed or deployed throughout most countries nowadays. And it's the 700 megahertz, which we call the coverage band. And it's the 3,500 megahertz, which is more a capacity band, because inherently in wireless communication, the rule of thumb is that the lower the frequency, the higher the range. But the higher the frequency, the more capacity you have. So this one is made for coverage. It's difficult to predict the range of communication systems or wireless communication, but maybe if you have enough power and good conditions, maybe 40, 50 kilometers could be covered by 700 megahertz, while the capacity band of 3,500 megahertz is maybe in the best case scenario a kilometer or two. So that's more for hotspots where you expect a lot of people to be using the band. So in cities, in stadiums, arenas, etc., where there are lots of people residing, that's where you use the capacity band. And for more rural areas, or for example for maritime use, it's the coverage band that you want to use. Now there's a challenge with this regarding the capacity of 5G when it comes to these two frequencies. And if we take Norway as an example, and look at let's say coverage band of 700 megahertz. Each of the three operators we have in Norway, they have 10 megahertz for uplink. That's from the user equipment to the RAN. And they have 10 megahertz dedicated for downlink from the RAN and to the user equipment. And this is from a radio perspective point of view, 10 megahertz is a very narrow channel and it's not capable of sending too much data. But using 5G technology and 5G radios, it's possible to calculate the maximum possible uplink data capacity you can have with a 10 megahertz channel. And that ranges from 7 to 55 megabits per second, depending basically on the signal quality and which modulation scheme you use. And this one is dynamic, so the longer range and poorer quality of your communication, you will decrease your throughput in order to get your signal through. And of course, this is not too bad, but then this is from one single base station. So if you have two users using the same base station with the same schemes here, you have to share the available megabits per second. So if you have 2 or 3 or 4 or 5 ships trying to connect to the same base station, you don't have that many resources available actually. On the other hand, in the 3,500 megahertz band, there are much larger bandwidths available, up to 180 for one of the companies in Norway. The maximum channel bandwidth for a single user equipment, on the other hand, is 100 megahertz. So it's not possible to use more, but of course you can create two different channels and cater to more devices if you want to split your band in half, for example, for Lyse Tele. In Norway and also in most other countries, however, this bandwidth is not divided by uplink and downlink, but in order to have synchronization between networks, the regulators in Norway and also in most other countries enforce the national operators or the mobile operators to use a 4-to-1 downlink to uplink scheme, which means that 1/5 of the capacity is used for uplink and 4 out of 5 is used for downlink. This is, of course, is okay for consumer applications, but in most industrial applications and maritime applications, it's uplink that's interesting. You want to send data from the ship to the shore, to the base station. So there are some capacity limitations, at least when you're using public networks for 5G. So if you do some theoretical calculation using 100 megahertz channel and the 4-to-1 uplink downlink ratio, you actually end up with a maximum uplink capacity in these networks from 10 to up to 143 megabits per second, again, depending on the quality of your signal and which modulation scheme you use. And of course, again, this is divided and shared between all the users of that specific base station. So another option from public networks is to use private networks, and that's new with 5G. With private 5G networks, the frequencies or some frequencies can be dedicated and allocated to private actors for local use in typically geographically limited areas. This is handled politically on a nation or a country-by-country basis by communication authorities in each country. And of course, this could be used for all the verticals in the country, like industry or healthcare or machinery and maritime and media production, etc., if each country allows for these frequencies. So as an example, These are some of the national regulations for private 5G frequencies across the world. You see France, Germany, Japan, Norway, UK, USA, and the frequency bands that are allowed for this change, but they have in common that they're in the coverage band. So this is intended for data transfer and not for range. And typically you have power limitations and also geographical limitations. So these networks are not intended for having large coverage, but more to cover an industrial site or a factory or perhaps an harbor in a maritime setting. So the frequencies are suitable for capacity, but not for range. Of course, there are more countries, and some have not yet decided on the use of private 5G networks and their frequencies. Others might have, but there are many countries and a lot of work to be done to figure this. But if you have any questions about your specific country, feel free to contact me and we'll find out together if it applies to you. So just as an example, for the license limitations we have in Norway, where I reside, we have the 3.8 to 4.2 gigahertz band. As a private consumer, you can ask or let's say pay for a bandwidth of either 20, 40, 60 or 80 megahertz. 80 is the maximum. There are two different power regulations, either low power or medium power. The medium power, where you can transmit with up to 64 watts, which makes this that you can have quite a decent range actually. That's not allowed in urban areas with lots of people. So it's only for remote areas where there are not that many inhabitants and things like that. But with the low power, you can use it everywhere, up to 1 watt. The annual fee is next to nothing, actually. It just basically covers the administration cost of the communications authorities in Norway. And it's a scale going from bandwidth and which power type you have. So for 80 megahertz maximum power, it's 3,800. And if you want 20 megahertz in the low power band, you only pay about 20 euro. This would be each year annually. I see time moves fast. I'll just speed through some of the example applications for maritime use. Kris and Kris will go deeper into some of them in the next presentations. So maybe the most common one is ship-to-shore communication, where you can either use the public 5G infrastructure if you have ships traversing large coastal regions or going in inland waterways, for example, where you have access to public 5G infrastructure and where it doesn't make sense to use a private network. If you're operating in a harbor or you have a ferry crossing with a limited range, for example, private 5G networks could be of interest if you want to have a completely isolated network that you're in control of yourself. Of course, this connectivity can be used for all kinds of things, internet and fleet control, condition monitoring, and remote control and autonomy, of course. 5G can also be used for onboard communication if you put a private 5G network on board the ship. From a regulation point of view, that's not completely handled yet because most frequent or the private frequency regulations is for a given fixed geographical location, but it's not considering nomadic network that move around and change location. So that's something that should be solved by the regulators before you can start doing this in a large scale anyway. And then finally, harbors. Private 5G infrastructure is ideally suitable for harbor operation, both with communication with ships, for automatic docking and mooring. If you have remote control or more autonomous ships, you can use it for crane control, and also for logistics and autonomy on the harbor itself. So that's all for me. And if I'll go to the chat now and see if you have any questions for me, I'll try to moderate myself. And thank you for your time. I'll switch windows here and see if there's anything in the Q&A. I don't see any questions for myself.
Yeah, I think there is one for you, Stig. Shall I ask you? So I think Michael asked, can network slicing be implemented in a mobile maritime environment?
Yes, definitely. Network slicing is basically just a virtualization of the network. So if you want to use the, let's say, public infrastructure, go to a mobile network operator, you can still get dedicated resources and ask for the capacity you need for your specific operation. And then you can be given your own private slice. So it's a part of the network that only you can see and only you can use. And yeah, I would say that's ideally suited for maritime operation, especially if you have, let's say, coastal near operations and you traverse a larger geographical area. That's very suited. You can also use it on harbors to segregate between different users. If you're the harbor management, you can have different slices for different users. So you can use one slice for, let's say, logistics on the harbor, a different slice for shipping companies when they want to do mooring and docking, etc. So slicing is very suitable for maritime operations, I would say. Are there any else, Kris? I don't actually see them in my view here, but maybe I'm on the wrong.
No, I think that's the only question thus far.
Ah, yeah, now I see it. There it was. Yeah. Yeah, unless there are any other questions, I guess we're right on time to start the next presentation. I'll stop sharing mine. And then we have Kris Vedat, Head of Technology and Logistics in P&O Maritime Logistics. And he's not going to focus on 5G technology, but rather what 5G can enable through its increased bandwidth and capacity when it comes to enabling large data flows and large amount of data. So, Kris, the word is yours.
Thanks, Stig. So as Stig mentioned, today what I'll be talking about isn't more around the technology, but what the technology enables from a ship operator owner's perspective, and some of the things that we are doing now that has been enabled due to the greater bandwidth that we're getting from 5G when we're operating in the more coastal areas, and also from other technologies like LEO and the KU bands that exist today, and what we now are trying to do with this to make the ship's operations more efficient and to give better experiences to our crew and our clients. So the evolution of communication has been changing over the recent years. And with that, the technologies that are in place have been advancing with the speed increases that we've started to see. So if we take it down to the original slower bandwidths that we had when we looked at FBBs, SAT-C was a common tool that was used for communication. As with the introductions of more of the traditional VSAT services, sort of email services became available, the use of internet on board, social media was able to be accessed. And as now we're advancing further with the new technologies that are in place, such as 5G and LEO, this is enabling things such as video calls, the better use of IoT technology. And we can see things like live streaming of TV becoming Netflix, Amazon, all of the sort of the on-demand streaming services are becoming more available to the vessels due to these increased speeds that are available now. And we the future holds other technology as well. Obviously, that will be enabled by the greater bandwidths that we're now able to access on board the vessels. And I think a trend that we're seeing now more and more, certainly from our crew and our clients, is that there is a greater demand for bandwidth. I think this has certainly increased and accelerated during COVID, where there is a greater demand for increased speeds on board the vessels, not only for operational matters, but from the crew. They're expecting this. They want to be able to access the same services and applications that they use at home on the vessels as well. So these new technologies that are coming into play are vital to enable these services and enable these capabilities for the crew and the vessel. And I think if we look at the trends that we're beginning to see in the marine sphere and the technologies that are going to, the trends that are there for 2030, there are several trends that are being paramount now. And I think the speeds and the bandwidths that we're required in order to enable this is essential. So, smart shipping is going to be one of these trends. It is estimated that 1 in 10 ships will be completely automated by 2030. Maybe not in all verticals within the marine, but in some marine verticals, we will see fully automated vessels or partially automated vessels as well. So it doesn't necessarily mean it'll be a fully automated vessel, but there may be partial functions on board the vessels that are automated. And this smart shipping, this smart vessel will become part of day-to-day operations moving forward. Again, advanced communications is becoming far more predominant. You know, we've touched on 5G, which is one of these advancements in technology, but LEO is another advancement in technology when it comes to communication. You know, I think these technologies are massive disruptors in the existing communication market in the marine industry, and they're allowing these higher bandwidths to come down to the vessels, which is then enabling these technologies that were not available before to be deployed on the vessels. We touched on the Internet of Things. So IoT technology is enabling us to better connect to the vessels and to get better information and data from the vessels, which also helps us to move into things like predictive maintenance, condition-based maintenance, getting real-time information from the vessels to ensure the uptime and the safety of the vessels. AI and robotics, I think AI is a big buzzword, and I think more and more in the last recent years, especially with the the rise of things like ChatGPT and Copilot from Microsoft, AI is becoming embedded in the day-to-day workings in the enterprise. And why would we not expect this to become part of the day-to-day workings of the vessel as well? So these technologies will most likely be coming into play, and the communication required in order to enable that will be essential. And if we take all of these things into consideration, we look at the big data analytics. The amount of data that will be generated from the vessels will only increase as time goes on. There's a lot of big data at the moment that is generated, or information is generated in the vessels that's not necessarily captured, but with the advancements in technology, with the advancements in the ability to get this information off the vessel, I see that these trends will only increase moving forward. And I guess more importantly, that these, the bandwidths and the increased speeds are enabling our crew welfare. I mean, gone are the days now that the crew would only contact their friends and family on a regular basis, by the limited communication methods that they had historically. They now want to be able to talk to their friends and family on demand, be that or a voice conversation over, WhatsApp or FaceTime, a video conversation. They expect that nowadays. And the good thing is that these technologies is enabling that for our crew. In addition, on-demand services for streaming and video content, these are things that now are being expected from our crew. And I don't think we're quite there yet, but I think the future, is very positive for this, that I don't think we're that far away that the crew will be able to access Netflix or Amazon Prime or YouTube or Disney from their own device on board the vessel when they want to, without any form of limitation. But if I step back more into data and the data flow that will increase with this increased communication, I think it's important to see that the global data sphere is changing dramatically. So historically, more data was generated from a consumer perspective than an enterprise perspective. Moving forward, it's predicted in the next few years that the majority of the data that will be generated will be enterprise-generated data. They're talking about now that they expect 175 zettabytes worth of data to be generated annually. And that number will then increase tenfold in more of a decade. So if you then think about how that is in the day-to-day living of enterprise, how that then will come from a marine perspective, the need to get this information off will become far more essential and important. And these new technologies like 5G and LEO will play a big part in that journey, in that story, enabling that data flow from the vessel. And if we think about it today, the maritime industry produces a huge amount of data every second. If it's AIS data for positional, we're looking at weather data. There's engine data, there's equipment data from the engines, for example. There's all of the data that's coming from the various IoT components on board the vessel. We have crew data, we have safety data being generated that's on the vessel that can be removed off. We look at from the port and the quay side, activities of berthing, all of this information is being generated as well. There's fuel data that's being generated. A very important component now today, certainly from a sustainability perspective, is the emissions data, and in general HSEQ data, which is being generated as well. And all of this data needs to be transmitted from the vessel to the shore side to be able to analyze it and process it, and then come out with predictive models, forecasted models. So we can start looking at real-time port congestion to reduce the amount of waiting time to improve efficiency. We look at the speed and the fuel monitoring perspective. How can we reduce emissions? How can we save from fuel costs? We look at optimizing visits to the platform to minimize waiting times. If we start collecting this data, analyzing this data, and then producing results from this data, it has a major impact, a major positive impact moving forward. I just want to touch on today about how we at P&O are using some of this data today, and not just in P&O. I can talk in general terms as well, but how data today is being used and how it can be used even more further in the future if we're able to get hold of, capture the data and transmit the data. So one example we have at the moment is the cargo optimization. So at the moment, historically, cargo delivery was done on dedicated voyages without a real holistic view of the data or the cargo, and no real-time analytics of the vessel movement. This resulted in reduced deck utilization because there wasn't real forward planning, and it was a very manual procedure because you didn't have the ability to automate a lot of these functions, and that resulted in minimal planning and very little visibility into the cargo status because there was no real-time information flowing from the vessels or from the cargo positioning. Now, with the enablement of data or the technology using things like AI and machine learning, we're able now to do real-time automated planning. So instead of it being a manual process, this then allows us to automate the planning of the cargo delivery, in this instance, in the offshore industry, to deliver the cargo to the various different rigs and assets that exist in the field. This allows us then to service multiple rigs and incorporate transfer between the rigs and the backloading from the rigs in an automated fashion, which then increases the deck utilization because now with planning and forward planning and greater visibility, we have more confidence in loading the back deck with a greater amount of cargo and increasing that utilization, as well as looking at optimized routing selections as well. With the ability now to take real-time data from the vessels, we can now plan more in advance because we have able to simulate that cargo routing better. But in addition, we're able to then make changes in real time in the event there's any changes to the scenarios or conditions while the cargo is being delivered. So if there is weather issues or there's issues with congestion, we're able to then in a real-time manner change the routing, the planning to optimize to ensure that we don't waste any time en route. And this then also enables real-time visibility for cargo because we're now transmitting this data real time. We can give better real-time visibility of where that cargo is at any given point. And because now we're collecting this data from the vessels and the various other elements or partners that we have in the process, we're able now to generate business models. So we can now simulate various scenarios. We're able to look at the various flow of the vessels' positions, the volumes of vessels in certain areas. We can look at the amount of cargo that's being distributed. We can look at patterns of where vessels are moving and accessing certain areas to look at the demand that's required, and then start generating our own business models based on that data. So if we're looking at new areas to enter, new business areas and new business opportunities, we're now making those decisions based on data, not based on any other sort of information, which makes it a far more sustainable and accurate method to be able to do business plans and business modeling. So with this information that we're getting from the vessels and various other sources, we're able to use this and then generate a more insightful view into our business models moving forward. And as I mentioned, we use now real-time analytics. So instead of having to wait for various information or wait to have this information come to us at a later stage, we're now taking this information in real time, which is far more efficient than it was beforehand. So now using AIS data, using data coming from the vessels from performance and fuel, we can now take that data real time. We're able to filter out any noise or bad data and then make more accurate decisions moving forward. We can optimize for SIMOPS traffic, looking at congestion. We can look at telemetric data from the vessel and from other sources. We look at fuel data and the speed of the vessels moving to truly optimize that vessel in a real-time manner when that journey is taking place, which historically was only done after the event. So now we're actually making these changes real-time as opposed to afterwards, which is providing a far more efficient and optimized service to the clients that we're servicing. In addition, we also start looking at crew performance as well. So because we're now looking at the crew and we're looking at the information that the crews enter in and the data that the crews putting into the systems from a maintenance perspective or from a HSE perspective, we're able to then start benchmarking the crews and the vessels and looking at the performance of them using data. So historically, if you're assessing the crew performance or you're looking at the vessel performance, it was based on someone's viewpoints to some degree. I'm not saying that it was a negative view or a positive view, but it was based on an individual's viewpoint on that crew's performance or that vessel's performance. Now we're able to take the data from the vessels and we're able to then assess them based on, benchmarks that were generated from the entire fleet, which is a far more fair and easier way of actually assessing how the crew is performing, how an individual crew is performing, and how that vessel is performing as well. And it also gives us an insight into that crew as well, and whether that crew or that vessel needs additional assistance, or we need to look at targeted training campaigns. If there's a continuous issue on that vessel, if there's a continuous incident on that vessel, we can now look at targeted campaigns for specific vessels instead of generic campaigns, which is far more efficient and far more beneficial to that vessel and crew. And as I mentioned before, fuel consumption is quite an important factor as well. So now we have fuel management systems on board, we have consumption systems on board, which allows us to, in real time, see the consumption of the fuel on board the vessel, as well as trying to ensure that we can optimize that fuel consumption on board the vessel. With the advancement in FMS systems, we can ensure that the vessel is actually running in the most economic mode at all times, and then we can look at the vessel and ensure that that's taking place and communicate to the vessel if that's not the case, because we have that connectivity now. This is great from an environmental perspective, from a cost perspective, and it gives the confidence to our clients and customers that we have full oversight of what our vessels are doing at all times, and we're monitoring this and ensuring that it is being optimized continuously. So these advancements weren't available easily beforehand in the later times, or it was very difficult. Now with the advancements in communication, this information is far more readily available in a real-time manner, which is giving us a great advantage from an operator and owner's perspective. As I mentioned before, with the advancements in IoT technology, now we're able to move into condition-based monitoring and predictive-based monitoring, which is an essential component when we start looking at the uptime of the asset and the vessel. So now with the IoT technology on board the vessels, we're able to identify issues occurring with the equipment and failures to the equipment before they're happening. And because we're getting this information from the vessel and it's being analysed, we're able then to assist the vessel and advise them of any failures on board. The vessel can also do this on board the vessel because the systems are there as well, but we can look at it from a holistic perspective and give advice to the vessel, and also look at the procurement of parts and equipment and plan for the maintenance to take place when that vessel comes to quayside or to dock or to dry dock, which is a far more efficient and optimized method of actually running your maintenance plans. And as I mentioned before, with AI now, we're able to bring the past data in and historical data to predict the future. So if it's for looking at maintenance plans, if it's looking at health and safety, if it's looking at routings of the vessel, if it's looking at the cargo that's being moved and the demand management of that cargo, using that historical data, we're able to then have a view of the future and try and predict the demands, the issues, what is going to be required in the future, as opposed to being reactive to it. This insight nowadays is essential for us to run a more optimized operation. And historically, that data wasn't being captured, it wasn't being submitted or transferred, it wasn't being analyzed. Now we're using all these various data, all these various elements of the data to get a far greater picture, a far better picture of how the vessel is running, how the cargo is flowing, how the fuel is being consumed, how the vessels are moving than we did before, which enables us to have a far greater insight into the day-to-day operations. And just to summarize, so what do I see what the impact of 5G and these other advancements in communication have enabled? So it is enabled enhanced connectivity at sea. So now we have better real-time data transmission. We have better communication, improved communication between ships, the ports and the shores. It's enabled improved operational efficiency. Automation now is far more embedded day to day. Predictive maintenance, real-time equipment monitoring is in place, enabling reduced downtime. Crew welfare is improved, improved communication for the crew to contact friends and family and access social media and streaming sites. And there's been a reduced environmental impact, optimizing fuel through the use of real-time analytics, optimizing route planning and, ensuring unnecessary delays has reduced, the environmental impact and improved the sustainability of the vessel operations. Thank you for your time, and I'm happy to answer any questions that have been asked.
Yeah, thank you, Kris. Excellent presentation about the use of data and what could be made possible through 5G and other connectivity solutions. I don't see any questions here so far. In the meantime, maybe I can sort of ask a question or just have some musings that seems to be like sort of opened up now for a lot of data, that 5G connectivity and similar. There's something now that's not been possible before, and it enables a lot of data. Do you think maybe we get a data demand that's too big even for 5G? That once you start using data, you just want more data. You talk about more and more data being produced. So maybe connectivity will be an issue again in a few years. So sort of in a battle here between capacity and demand.
I think it will be, and I think I was trying to, on my first, I was trying to demonstrate that as technology advances, the bandwidth will have to advance at the same rate. And I think if I look at the maritime industry, I guess arguably bandwidth has been a barrier to that. We haven't been able to embrace the technology advancements that you see in a day-to-day in your day-to-day office or enterprise environment. That's been restricted from a vessel perspective. I think nowadays that barrier shouldn't be there, and I think LEO and 5G has helped break down that barrier. But you're right. I think, like anything, the more used you get to something, the more you consume, the more you want, and that will happen. I think I don't know what the future will hold and what the next generation of bandwidths will be, but I certainly see that this will only increase. AI is a new thing, and it's not fully being utilised, certainly from a marine perspective, in the most optimised way. That will happen, and whatever the next wave of technology will be as well. I just hope now that from a marine perspective that we keep up with the demands and not get restricted from the limitations we've had historically.
I mean, I would add to that a little bit, which is that maritime, particularly globally trading vessels, they are particularly critical in terms of the availability of that communication. So if you compare it to, I don't know, in outside of commercial operations, say in your operation at a train station or a football stadium with thousands of people, that scenario, people can accept to a degree a dropout or a limited accessibility of their communications. But throughout, although we're going to get, like Kris describes, a very strong increase in the demand, that's going to continue. But the requirement to always ensure access is quite particular in maritime, as it is in other areas like aero as well.
I agree, and I think the uptime or the availability of that communication is essential, because it affects day-to-day operations, and a breakdown in that communication has a repercussion. But I think one of the other things that, and I probably didn't touch on it in the presentation, is that I think data is going to grow. It will grow, and there'll be more data being generated as time goes on. But I think one of the things that the maritime industry has probably not really done well is standardizing that data. So if you look at the aviation industry as a good example, they standardized data very early on. The maritime industry hasn't really done that. I mean, if you look at it from a liner industry or container industry, they've got your EDIFACT messages for Codeco. But if you take it from general vessel operations, there isn't really a standardization that exists. I mean, you don't even have a standardized noon report as an example.
That's right. It's amazing. No standard format for that message that every vessel sends. And
I think now that will have to change. I really do believe that now we're moving into a world where there's going to be a greater demand of data coming from the vessels and the marine industry as a whole. We're going to have to work backwards and sort of get those standards in place, because otherwise it's going to become very difficult to communicate, collaborate, and it will happen, right? Vessels are called in ports, they're called in rigs, they're called in whatever it is, and there's no standard communication between the two. Moving forward, that's just not a sustainable solution. The automotive industry standardized, the aviation industry standardized. The maritime industry is the oldest industry out of those three, and it hasn't standardized because it didn't have to, because it started so early on. We really are going to have to look at that as an industry at one point.
Yeah, very good points. I see there are questions coming in here, but they're all related. So maybe we have a Q&A session at the end. So maybe we can collect them all and do a broader discussion on it then. And we'll do Kris Insall's presentation first, which is 5G and satellite communication, which is also highly relevant. You speak of LEOs, Kris, and then, yeah, the other Kris. So we can do, Kris Insall can get his 15 minutes and we'll continue the discussion afterwards.
Just share my screen here.
Yeah, so you're the head of mobility business development at ST Engineering iDirect. And yeah, you're going to talk about satellite and 5G. And you have a background from satellite, is that correct? Prior to joining ST Engineering?
Yes, so thanks Stig and thanks Kris for that. Yes, I've been in the industry serving mobility and maritime for over 20 years, working in satellite sector and also in the related technology sectors around satellite and connectivity. Thank you very much for your session so far. Very interesting presentation from Kris for that, and very, very good insights from on the ground, from the port perspective and from the vessel perspective. We're very glad to sponsor this session. I'm going to be telling you a little bit about what our company is doing in the field of connectivity, and particularly in terms of working with 5G standards. So I'll get on with that. And just really to start off with, for those who don't know ST Engineering iDirect, some insights into our company. So as described here, we're a strategic ground technology partner to the satellite ecosystem. We are very well established, over 35 years in operation. We have more than 1,000 employees and global presence in HQs in US, Singapore, Belgium, and I'm calling from the UK today, London. We have a wide product portfolio. It's part of a very solid corporate structure. We have ST Engineering, our group, has a market cap of over 9 billion USD, and our company operates in different sectors, commercial and government. We have a dedicated government subsidiary. Today we'll be focusing on commercial items. And for those in the industry, in maritime, you may or may not be aware of the modems installed on your vessel for VSAT, but the likelihood is that it is one of ours, an ST Engineering iDirect modem. Got a couple displayed here, the 3315 and the 5010 at the bottom. So we offer really the best connectivity experience to our vessels, and we have the modem I mentioned provides the highest throughput on a single modem link, up to 1.6 gigabits. Our specialty includes global bandwidth management across the entire network, and that's across a very wide range of network terminals and compatible applications. We operate several standards such as OpenAMIP and OpenBMIP. And in March, we announced the new next generation platform, Intuition. This is a single platform focused around improved connectivity, multi-orbit functionality, and operating a standards-based design, including 5G network systems. And that's something that we'd like to look at in more detail now. So I thought it would be interesting from my own personal perspective to share with you the journey, a couple of journeys in parallel. So the cellular journey from 1G to 5G, but also the maritime and satellite journey that I've experienced. It was interesting to look back. So the first systems I was working with in Inmarsat A, these were essentially analog systems, and these were analogous to the cellular systems, the 1G cellular systems, and interestingly, they suffered some of the same issues, like you might remember phones being cloned. In actual fact, some of those analog systems were being cloned as well in the background. You may not have known that. A lot of those issues were resolved with the introduction of new digital technologies and great advances on the handset side, on the cellular side of things, but also access to true digital services, and also the rollout of TCP/IP, true TCP/IP based services. And on the terrestrial cellular side, there was a notable improvement in that standards converged. It was possible to travel to certain countries like Japan without any longer having to have two separate handsets. And on the satellite side, yes, I remember at Inmarsat, I was working there. We launched the BGAN-based systems, which were 3GPP-based systems. Meanwhile, on the terrestrial side, people might remember some of the more advanced 2.5G and 3G systems, and systems like WAP and MMS. So new services were rolled out, but increased and improved very greatly with 4G and LTE, and up to 180 megabits maybe possible on 4G, although in practice you didn't get that yourself individually. But on vessels, there was also the expansion of VSAT. So now we have tens of thousands of VSATs deployed with megabits of connectivity. to realize some of those key requirements that Kris Vedat was talking about previously in terms of data usage. But 5G meant that performance was significantly improved, and in theory, on a 5G system, it's possible to access up to 10 gigabits. In practice, that's not the case for many people. But on the maritime side, in the meantime, the standardization, people really being used to carrying their devices, their standard 5G devices on board, and being able to access different applications. Now, what we're not talking about here is universal delivery of GSM on ships, although there have been lots of projects doing that in the past 5-10 years. Generally, it's the access to connectivity via Wi-Fi, for example, the same as you would expect at home, and that is the direction still forward. And what we're talking about with 5G here today is really the infrastructure technology that Stig referenced at the beginning, the NTN, non-terrestrial network component, which we're building in the background. Just a note to say that it's interesting how both satellite and cellular are kind of interdependent or complementary. So 5G, you can say, helps satellite in that it provides the standards that are needed really to ensure consistency and scale as well, and systems for management and orchestration, again, at much greater scale than satellite provides. On the satellite side, it helps 5G in many respects. So cellular backhaul, for example, in remote locations, people might be aware of, it runs via satellite, but also very specifically the coverage that's available that just isn't available from a 5G base station. But also increased resilience and security as well. In this day and age, the backup with the current geopolitical developments is a key theme. Backup of terrestrial technology by satellite. So yes, there's a two-way relationship going on there. From our perspective, it's a key time. We're rolling out new systems. And in terms of our next-gen systems, 3 areas I wanted to mention. So what focuses us is the standards. 5G absolutely is part of that, providing a universal architecture and some interoperability between systems and giving access to something which will be hopefully very seamless. Virtualized technology, so we are moving towards cloud-based systems, and our base stations our hubs are able to be accessed via the cloud as well as on premises, but also giving far greater scalability. And orchestration is absolutely key. So when we're talking about the numerous systems we've been describing, including 5G waveforms, it's essential to be able to orchestrate all these different layers together. And these are our key priorities at the moment, bringing that forward. But we do listen to what the market is telling us. And as Kris mentioned earlier, the interoperability is absolutely key. The need to have seamless services operating in different technologies and platforms. But what is essential is that we pass on cost savings and the access to greater scalability. And we were talking about non-geo systems earlier. So non-geosynchronous systems our compatibility with multi-orbit systems is absolutely essential and prime in our planning. And we have considerable innovation at the moment running to that end. I'll talk about that in a second in terms of proofs of concept. But at the end of the day, there are new standards being implemented, and we need to ensure we're future-proof in that. So this is just to look at the key architectures that we are exploring at the moment. So I mentioned that it is in terms of the waveforms. That is our key focus. Stig mentioned the NTN. There are three key models on the right here, which represents the mobility side. We have our existing traditional VSATs, but we are also looking to enable VSATs with a 5G core. So our satellite operator customers who implement a core network that is a 5G core, they want to be able to ensure that there is the control of those mobiles. And there are various systems we are working on that the industry is in development mode, looking at these technologies that are termed internetworking functions, or IWF. And there are a couple of different angles that we are looking at in terms of access gateway functionality to deliver that. But also just enabling the waveform that we talked about, the pure satellite waveform. So the non-terrestrial version of 5G, as mentioned by Stig, this will be very, very necessary to include as an option in our next generation systems. It may be that those waveforms are not necessarily the most efficient, but it's a question of determining the best waveform for the usage pattern, where there is the requirement for it for better scale or access to a wider customer base. Then we will ensure that it's possible to access the 5G forms. But it may be that in other formats where we have the best waveforms available. Stig mentioned the limitations in terms of uplink, for example. So we have some waveforms which are totally optimized for very high uplink throughput. Also on the radar here is the direct to device. So I should mention that that is going on. So you will see out in the industry that there are various developments ongoing. That is not actually our focus so much at the moment. Then the direct to device 5G systems are really lower performance and IoT based. Our focus at the moment is in updating and enabling VSAT. So I hope that gives you some insights. This slide is really just for reference for those very interested in what is happening in terms of the 3GPP and ETSI. The releases that are currently under development, and it's just also to highlight that it is a real thing. So 5G over satellite is a real development. We've had release 17 of the 3GPP, the standard, that was restricted to L-band communications. Release 18 then added Ka band, and what is ongoing now is release 19, which also will add Ku band. So opening up to the full range of VSAT connectivity. Also, not to go into all of these, but this is just an illustration. I mentioned that key for ourselves for ST Engineering iDirect are the proofs of concept. So 5G has been around now for around about 5 years. And for about 4 of those, we have been developing groundbreaking proofs of concept to show 5G operating from space and in space. So a list of some of the projects here. In particular, I mentioned ESA. So ESA as a partner, they operate the NTN Forum, which has over 140 companies. And we're participating there in 3 different working groups to bring these standards forward. But they have been a key partner with us in terms of rolling out some of these proofs of concept alongside 5G, but also cloud capabilities and non-geo satcoms, which we are now able to support as well as geo satcoms. So in terms of our own path forward, as I say, we are now rolling out our next gen system. These are quite high level goals, but very important ones. So we've said that we are looking to embrace the telco model. So, the difference between telco and satellite, historically, satellite has been slower to bring technologies to market. And so we are looking at providing the same digital transformation as mobile operators or cloud innovators, and the same advantages of speed to market. But we do that with an ecosystem that is supported in terms of our satellite operator customers and hardware partners. But all in all, this is how we intend to move forward in delivering more advanced and seamless global connectivity, and 5G is a very important part of that. Okay, I will finish there, and thank you for your time. So I hope you've been able to have a good insight into our view and our activities.
Yeah, thank you, Kris. Really insightful, and see how 5G and satellite seems to be actually merging over time and embracing some of the same concepts delivered by 3GPP. So I guess we have more questions now, and some may actually be for just your presentation, Kris, but there are also some older questions for all of us, I guess. So unless you object too much, I guess we can just do the common Q&A now, the three of us. And I'll start on top on the published questions here, and there are actually two questions on the same topic related to the cost of connectivity, cost of data, cost of communication, and how we see that's going to work. And that it's going to be prohibitive for development, especially with the dominance of Starlink, is mentioned here in the market for LEO broadband. And yeah. Any thoughts on the cost perspective related to communication?
I mean,
Maybe.
I have a view, I guess. I think that historically the cost has been high because it's been somewhat monopolized, I guess is the argument that we said. I think at the moment when we look at Starlink and the LEO services, yet they have the majority. They have a monopoly at this point. OneWeb, Amazon's products isn't out yet, but it's potentially coming. I think the costing will be determined by competition. And I think there's lots of LEO services, if we're going to talk about LEO in this instance, that are coming on board or will be on board in the future. And I think that will then, market conditions will then dictate the costings. So I hope that the costs don't make it, don't become a barrier to enabling greater bandwidth on board the vessel, because I think historically it has been, and I'm hopeful. LEO is disruptive, Starlink is disruptive, but I think the competition will, dictate the market rate and hopefully keep it at a level that's more sustainable.
I mean, I'd comment to that. So de facto, what we are seeing is a requirement for hybrid communications. So the ability to add different layers of connectivity where needed. It's kind of interesting. Here, say we were at SMM last week in Hamburg, thousands of people there, but lots of stories there about different histories and different experiences in terms of billing. It's true that with some systems which are higher speed comes higher costs because you're very often paying by volume and balancing off different systems. So 80% of IP traffic or more is actually video. We talked about providing video and streaming for crew, but it's a balance. So there are circumstances where you might be better off to use TVRO functionality, which is best delivered by geosynchronous satellites, which don't need to charge you for IP usage. So there's a range of balancing systems, and at the end of the day, the service providers play an increased role in making sure that you have balance, you have access to the services that you need, the global services and the quality of services that you might have from an established system, or access also to higher burst services as you need it. And that's a bit similar to 5G. When it was rolled out, for example, in the Mediterranean, a lot of vessels were able to add on additional layers of burst connectivity to their established SATCOM. But the customer, of course, requires a seamless service and makes sure that the service is also controlled from a cost perspective.
I agree. Today, as it stands today, hybrid is probably the way forward because these are emerging technologies. They're not mature. Certainly Starlink, I wouldn't potentially classify as an enterprise solution at this stage. My view is, though, that this will change in the future like anything. It will become more mature, it will become more embedded, it will become more stable, and then it will become the norm.
I think also it's important to distinguish between, let's say, ocean-going vessels and vessels that operate more in coastal waters or inland waterways or ferry crossings. And I think the closer you are to shore, the cheaper communication is going to get, probably. But even the mobile network operators are feeling the competitiveness, because I've heard somewhere that everybody has a cell phone now, so there's no longer any growth in the, consumer mobile market. But mobile operators need to show growth for stock markets, etc. So now it's about connecting the industries. And nobody knows yet, but I wonder for myself if you want to have, I talked about network slicing, that you pay to have a reserved capacity in the public network. I have a feeling that's not going to be cheap, but who knows? So even if you're at a harbor or going somewhere coastal near, it might at least initially be quite expensive to reserve the capacity or the quality you need for your data in order to do the things you want. So then it comes down to competition again. In Norway, we have 3 operators. Maybe they will start competing for the industrial market and push prices lower, but I think that's a bit further ahead, actually. So like with Leo, I think even 5G still in inland waterways or coastal waters, it's going to be expensive, at least initially. Unless, of course, you just buy a SIM card and hope for the best and do not reserve capacity. Of course, that's an option. Yeah. Let's see, I'll scroll on the questions. This was about cost. Somebody asked how much of the data is accessible to outside networks, like birds, freight forwarders, tax authorities, and if there are any network integration, and who would you argue are the champions of these platforms? I guess that's for Kris, Vedat, maybe, with data availability, who has access to data.
I think that comes back to what I said originally, the standardization of data doesn't really exist. So, I mean, if you look at manifest data that has to be submitted and those sort of things are standardized, but I think it's limited data points that are available to be standardized. And I don't think there's anyone really in the market, certainly from a marine perspective, that is enabling this as an industry perspective. I don't think it exists. I know in the aviation industry, you've got companies like SINTEF that does this for the aviation industry. That hasn't happened yet in the marine industry. So I think it will. I think there's a gap, in my view, that is there for someone to enter, to start being the integrator of choice, the standardizer of choice, the communication method of choice, the collaborator of choice. But at the moment, I just haven't seen it.
I think it's also pulls back to what we discussed earlier about data standardization, that there's a lack of that too, the data formats and how you actually represent the data. That's also missing in the maritime industry compared to other industries.
Exactly, and I think that's, there's going to be a prerequisite. If you're going to start looking at better data collaboration, we've got to do a few steps back first, and we've got to get the prerequisites right. And we're not there yet. I think that and they are happening. Those discussions are happening at IMO. I think it's just the emissions capturing and submissions is driving these conversations, but we're not there yet.
Yeah, I think it's going to take time, and all IMO is doing it, but it's not something that's going to happen, at least in the short future. I think it's
not a short-term fix for sure.
No. Any comments from other Kris or
not on that? No.
Yeah. Yeah, so data quality, there was a comment actually that I talked about data amounts. It said that it's going to be, it's not about the amount of data, but the quality of data. And I think that's actually a good point as well, that maybe AI and machine learning and things help you do analysis and, let's say, tune the data on board the vessel before you ship it to shore maybe in the future. So it's about the quality that the data you send is actually of importance and has some meaning and information embedded in it.
But I guess that argument then goes back to standardization to some degree as well, because if you standardize, you can put validation in, which then enables better data quality, right? I think those are some of the steps that enable those things.
Yeah, that's also what in the comment here, that data quality is something addressed at the moment at IAX level. So a framework is indeed established for it, but yeah, still need some steps ahead, I think. Let's see. There's another question. With the rise of low-cost LEO satellites and the decline of traditional maritime GEO VSAT, do you expect a reduction in hub deployments and availability as it becomes more challenging for operators to manage teleports, resulting in less traditional shared maritime VSAT services available? Wow, that's a long question, Kris, but...
Yeah, it's a long question. I'll take that one if I may. So
yeah, it's aimed at you, I think. Yeah.
In actual fact, I mean, there is a tremendous improvement in the rollout of services under GEO at the moment. That is the case. So coverage that is now delivered over KU band is what was actually only available previously over L band and C band, with C band with the 2.4 meter antenna size. And the capacity being put up into space for GEO is increasing very significantly with the deployment of software-defined satellites. So some operators in just a couple of years are quadrupling their capacity deployed. Equally, it is the case that, as we said, sort of globally trading vessels are maintaining those GEO VSAT systems to ensure that they have a baseline of capability in all the areas they are trading. So I think it's a balance. At the same time, though, like we said before, there needs to be more dynamic delivery of services and more intelligent selection of services with the new non-GEO systems that are being deployed, and that's what we are saying we fully embrace, and that's what at service provider level the value add that they are delivering now is to make sure that not only is the service improved and you have access to some of the newer services, but also it's seamless and consistent.
Yeah, a good response, Kris. There are a couple of other satellite-related questions here on both target Starlink and its impact. Somebody asked about the pros and cons of Starlink and and what impact Starlink actually has for 5G for maritime, and some considering, I guess you again, Kris, as a SATCOM.
Yeah, I mean, so our approach is like we've described. We're looking at standards-based adoption, and that is across really a large forum of different partners. So that kind of differs really from the new services, that the new LEO services that are being described here. But yes, it is very interesting. We've said that the reality is that there are absolutely fascinating and interesting new LEO services being described. There's 4 probably that are of key interest to customers to look at and consider, not just the Starlink. What is essential is that service is delivered where it's needed, that you don't have dropouts in service in key geographic areas, like entering port in China, for example. You need to make sure that is available. We heard last week that some regions were switched off. Also hear about countries' decisions that are looking to work or not work with for example, X or Twitter, and how that might affect services on something like Starlink. Won't speculate on that, but at the end of the day, again, it comes back to making sure when you're a vessel, you need to have no outage at all. You need to have a delivered quality of service, and that quality of service comes on a contract. If you can't contractually guarantee that, then you need to make sure you have other options available.
Is it possible to get contracts like that with a company like Starlink? I don't know, but
So I ask them.
No. Yeah, I don't know either, but I'm guessing not. Yeah, another question. I'm not sure for who, but wondering about ballpark numbers for split of bandwidth per service on board a vessel. So between crew, IoT, ship management, etc. Any of you have any insight into that?
I can only comment on my fleet. I can't comment as an industry as a whole.
No, it's a difficult question, I think, and it depends on the ship and what systems you have, and type of vessel, type of operation.
And we in instance, we don't split it that way. We have quality of service on board, and depending on the demands, it will decrease and increase depending on the traffic that's flowing at that time. We don't segregate it, split it rigidly like that. If we look at a percentage of data at the moment that's traveling, the majority is crew, as in volume wise. That's what the volume is today.
Yep.
Yeah, that makes sense.
I'd echo that from the information I've seen, and see the questions from my colleague Samir. So yes, Samir, I think it's around about 80 to 85% from the different surveys I've seen of the sheer data quantity is crew usage. But of course, the grade of that service, the criticality of it is lower than the access to bridge communications for the crew, being able to enter port and to provide all the essential operations. In terms of IoT, yes, still the IoT systems are extremely efficient, operating predominantly on L-band. So as a proportion of overall data, very, very small.
Let's see, there are more here, and you keep coming, so I guess we'll just keep on going until 4:30, or 5. Is it 3:30? 4:30 at my time, at least. CAT +1. So new question: what do you think is the main decisions that need to be addressed to be able to gain all the benefits from maritime connectivity?
So I guess, that depends on what the requirements are, doesn't it? So you've got to analyze, like we were just saying, analyze your requirements. And in Kris was talking about his fleet, not necessarily dividing up those use cases completely physically. Some customers do need to do that and keep their crew on an entirely separate network that can't at all bring down the connectivity on the vessel. So I guess it depends on the specific operational requirements of the ship.
Yeah, and I think just to echo that, you've got OT systems, for example, they need to be on a separate VLAN with a dedicated, I think security becomes a more, it is a big discussion nowadays, it becomes even more essential, the greater increase of bandwidth, the more systems we have on board, cybersecurity becomes a far more predominant factor surrounding that, as a security list.
Yeah, especially when you go to more remote control and more autonomy and lesser people on board. And
exactly. I think with the advancement in technology, the risks are also increasing. Those risks need to be mitigated. Yeah,
definitely. So let's see. How do we see the development of EDES as a successor to AIS? Will this have any impact on 5G maritime?
Not as far as I know, but Kris, is P&O involved in trialing the new VDES?
No, we're not at this point. We've been made aware of it. I'm not sure what the impact will be, if I'm honest with you. At the moment, we're predominantly AIS.
I would say it's a complementary service to 5G. Actually, 5G just provides connectivity, not so much else. But AIS or its successor is completely different systems, aren't they, for different purposes?
AIS is more about positioning, from my understanding. It's all about positioning where the vessel is, and then you're using that positioning to then look at all the other parameters telemetrically around that. And AIS is there as a safety.
Collision avoidance. Yeah.
It's there. It's there to give positioning of the vessel. Sure.
Yeah, so to me, 5G is something different that provides connectivity and just data from ship to shore in a way. So yeah, I think they will live side by side. And let's see a follow-up here. How will we convince the IMO to use these 5G radio communication systems also for safety with GMDSS, for example?
I would say that from a safety perspective, the issue with 5G is at the moment it's very much restricted to a certain area, right? If you're out in Antarctica, further north you go, Antarctica, you lose reception, right? It's just not going to be available. Yeah. So I think until there's a more stable global coverage solution, these existing technologies will play a part still.
And that is the aim. The aim is to extend that and use the satellite infrastructure to extend availability of 5G services in different ways.
Yeah, since that's what you're looking at, Kris, with the integration of 5G concepts and standards into your VSAT system, I think that's that hybrid solution is really the future.
Yeah, it'd be key, I think.
Yeah. Let's see, there's one more here. That one is probably for you, Kris Insall. What do you think will be the impact of a non-terrestrial network direct to device? Will it be connecting to routers and not only phones? Yeah.
Interesting question. I mean, I would at this point highlight, from the satellite industry, we're in a very different kind of scale to terrestrial communications. I mean, a massively different scale. And so producing standards that apply for satellite connectivity globally, it's an entirely different game to what we've been doing to date. So enabling existing systems for 5G, that is our focus. In terms of direct to device, it requires an entirely different approach. If it's going to be done globally, then you need industry providers who will offer systems at scale, and that is not the focus that we're able to give at the moment ourselves. So we are operating in industry. There's probably 50,000 ships or thereabouts that are our key focus globally, that are major users of satellite communications. When we're talking about direct to device and NTN, the sphere is just massively bigger. And again, the questions are different, the scale is different, and the commitments from industry players are different. So we're not focusing ourselves on that area at the moment.
Yeah, good answer. I don't have any follow-ups to you, Kris.
Not mine.
Oh, so that was the final question we have in the chat, and I see we have 2 minutes left. So unless Kris and Kris, do you have any final comments or remarks before we?
No, just thank you, and good to see all the interest and all the different questions coming in.
Yeah.
Thanks to my fellow panelists. It's been an interesting discussion.
Yeah, and me too. Thank you all. And I've seen we've had over 100 attendees and lots of good questions, good discussions. So on behalf of BS Group, thank you for participating, and also special thanks to ST Engineering for sponsoring the event. And it will be available on YouTube, I think, afterwards. And if you're interested in the files for the presentations, you can email the BS Group and request PDF versions of our presentations. So I think that's all for now. And thank you. Good afternoon.
Thanks, guys.